We just studied how to use the fundamental theorem of calculus to evaluate a definite integral. So you have a definite integral, and then the first step is you take the antiderivative, or you integrate the function, and then you plug in the upper limit, and then you plug in the lower limit, and then you subtract the two results. But what does that mean? You might say the result of the definite integral is equals to the area under the curve of f of x, where x goes from a to b. Yes, that is correct. But what if we put that on an application problem? That area can mean something else in an application problem. So let's put that in this application problem regarding velocity. Read the problem first. A bungee jumper jumps off the platform at time t equals to 0 and rebounds once during the first 7 seconds. The velocity of the jumper is represented by v of t, t is the time in second, equals to negative 5t squared plus 25t. So this the negative 5t squared that tells me that this is a parabola, concave down or opens down. And then the unit is meters per second. And then here is the graph of the velocity function. I asked 3 questions. How many meters does the jumper travel during the 7 seconds? So we are definitely taking an integral. But what is the result mean? The result, you might say, oh, it's the area. You already highlight the area, but what does that mean in this problem? So let's go back to the left sum method. So let's say for the left sum, we take a point at here, right? And then we go like delta x, and then we line up with the x-axis, and then we have this over here, right? And then this one, the base is delta x, and then the height is the velocity, right? So the base is the delta x. So let's write this down. The base, the delta x, is the base of the rectangle. So that is time in second. And then what about the height of the rectangle? The height is equals to, so you select an x value, you plug into the velocity function. So let's say t equals to 2, you plug it in, you get a velocity, right? So the height is equals to velocity at time, velocity, I would just say velocity at time t. So what is the distance equals to? So we have a distance that is equals to velocity and then times the time, right? We do not have any specific value. Just tell me what is the unit of velocity. The unit of velocity is in meters per second. So it's in meters per second. And then you multiply. What about the time? The time is in second. So how does the unit works? The unit, you just get rid of the second. So the distance is in meters. So what does that mean? That tells me that this area is the meters travel. So this area is the meters travel. So the area is the distance, not meters, travel, or distance in meters travel, or distance travel in meter, whatever you like to say. All right. So whatever the area of the rectangle is, that represents distance. All right, not area under the curve, that represents distance. Okay, let's answer the first question. How many meters does the jumper travel during the I think that should be during the first 7 seconds. Okay, so that will be an integral from 0 to 7, right? Okay, I'm going to write this down first. So I'm going to do it like that. So I'm going to do an integral from 0 to 7, and then our velocity, and then dt, right? So in the picture, do you see that we have 2 pieces of area? From 0 to 5, that is above the x-axis or above the horizontal axis, and then from 5 to 7, that is below the horizontal axis. So that means from 0 to 5, we are going to get a positive area. From 5 to 7, we are going to get a negative area. So we can break this down into 2 integrals. One from 0 to 5, so v of t dt, and the other one is from 5 to 7, v of t dt. The area under the horizontal axis is negative. So let's handle the 0 to 5 first. So we have integral 0 to 5, negative 5t squared plus 25t, and then dt. So we integrate the negative 5t squared. So the t from 2 plus 1, you get a 3, right? And then you have a negative 5 divided by that power, and then plus t squared and then you have 25 over 2. Before we proceed further, when you take the derivative of this, you can get back to the velocity function. You can do a quick check, bring the 3 down, bring the 2 down, you get back to the velocity function, and then such that t goes from 0 to 5. And then you apply the fundamental theorem of calculus. So you have a negative 5 over 3, and then you have a 5 square, not 5 square, 5 to the third power, and then plus 25 over 2, and then 5 square. So this is in one piece, and then you subtract the 0, right? You plug in 0, you get nothing, but let's write it down anyway. Times 0 to the third plus 25 square times 0 square. Because I would like to use this for the next integral to the square. Okay, so the 0 gives you nothing, and then this one I'm not going to do an approximate. I won't report the fraction to you. So this is approximately equals to, again, is approximately equals to 104.17. Now here is the question, what is the unit? This is the area under the curve. The area stands for distance traveled, so this is 104.17 meters. And then how about the other integral from 7 to 5? So from 7 to 5, we have an integral from, actually from 5 to 7, we have negative 5t squared, and then plus 25t dt. So this one, you can just use this and then change a little bit of information. So from 5 to 7, we will be using the 7. So this one, you are expect to plug in a 7. This you are expect to plug in a 5 instead of 5 and 0. So when you subtract the result, what do you get? So this one, let me just go straight to the answer. So that is equals to negative 16.63. This is also in meters. But how come the meters is negative? How come the meters is negative? So let's go back to the case scenario. The jumper jumps off. So when the jumper jumps off, the distance travel increasing dramatically, right? And then bounce back up. So this is from 0 to 5. The meters is positive. So what that means is the 107.17 meters is jumping downward. So this is downward, because the distance between the platform and the jumper is increasing. So that's why the meters is positive, and then the negative. So you jump all the way down and then you rebound, right? So when you rebound, the distance between you and the platform is decreasing. So that's why there is a negative. The negative means the bouncer is rebounding backwards. So this is meters upward toward the platform. So that's why we split this up into two integrals. And then have we answered the question yet? How many meters does the jumper travel? Have we answered this question yet? The answer is not yet. So here is, we are going to answer that right now. So what is the total numbers of meter travel? So the total is equals to 104.17 plus, look, 63.63. That's why we have to split up the two integrals. If you do not split up the two integrals, the answer becomes 104 minus the 63. So you are losing 63. I am counting the total number of distance travel, including the going down and then bouncing backward. So that's why we add them. So that is equals to 167.5 meters traveled. So here is the graph again. So we have the horizontal axis, the vertical axis. So here is the parabola, and then this part is 104.17, and then this is a 63.63. We have to split up the two integral, because if we don't, then we will miss the minus. All right, so that answers the first question. The answer is 167.5 meters travel. And then the next problem is at the end of the 7 seconds, how many meters is the jumper below the platform? So remember that the jumper went 104.17 meters down. So for part B, here is the answer. So for part B, I'm supposed to be using the pen, right? Not the highlighter. So for part B, the answer is 104.17 meters down. Let's see the question again. How many meters is the jumper below the platform? So that is this. So this is only from integral from 0 to 5. V of t dt. And then wait, hold on. So that is this, and then we bounce back up. Oh, you know what? Not yet. That many meters downward, and then we will have to subtract them. So we will have to subtract them. So that is 104.17. Wait, hold on. At the how many meters is the jumper below the platform? Yeah, we have to subtract them. 104.17 minus 63.33. So that is equals to 40.84 meters below platform. And then what else? The last one. What is the entire integral represent from 0 to 7? So for part C, you go from 0 to 7, Vt dt. What is that equals to? Actually, what is that equals to? If you consider that, then you have to subtract them. So if you consider that this, so this one you will have to take the result of the first integral, 104.17, and then you have to subtract 63.63. So that is equals to 40.84. Oh, let me say one more thing. Why do we have to subtract this? Because the jumpers went that many meters down, and then eventually go back up a little bit. So you have to subtract them to get the difference. It is not just 104. Once again, go back down and then go bounce and then go back up a little bit. So this is the number of meters below the platform. All right, so you have to write this down. Okay, what are we trying to say? So if you do this, so if you just evaluate the entire integral, then you will have to consider the minus. Then you will take the area above the x-axis minus the area below the x-axis. Then you will get that many meters. So what is that represents? There is a name for that. This represents net change. And then what else we can say? I would say that this is also the number of meters below the platform. Yep, because that is the same thing as this answer. So that is the number of meters below the platform. Once again, the jumper go all the way down. So at this point, this is 104, and then they bounce back up, and then that many meters. So this the number of meters below the platform if you evaluate the entire integral. Alright, so that is the end of this video. If you like the way I explained this, give me a thumbs up, subscribe, and I will see you all in the next video. Signing out.